Creating a part, what you always want to do is create a sketch on a plane. Now, for this particular part, we're going to start with creating a plane. So this button here for plane actually creates that plane. So let's go ahead and just go to our front, click on front, and then if we hit N, it'll normalize that view so that we're viewing the front. We can go ahead and hit plane, and then it's going to ask entities and offset. Let's go ahead and put let's go ahead and use offset, and for entities, let's go ahead and click on the right side, the right plane. And so then looking at the front, you can see that it's offset at 25 millimeters, but let's go ahead and click this directional button, and that will offset at 25 millimeters in the opposite direction. So then you can see now we have this plane here and this plane. So our right plane might be easier to see this way. We have our right plane, and then we have plane 1. We can go ahead and right click on this and say rename, and give this plane a name and call this left part plane. That way we know that this is a plane that we're drawing the left part on. So if we turn to the left, we click on the left part plane, and then we hit sketch. Now you can see the sketch plane is the left part plane, and we're sketching on that plane. So now we're going to go ahead and create the square, and that square is going to be roughly 50 millimeters by 20 millimeters. So right here we have the corner rectangle tool. You could also hit the down arrow and do center point rectangle tool, and that's what we're going to do because we want to create that rectangle right in the center of our sketch. So let's do center point rectangle, and we're going ahead and constrain that to that point. You can see it's expanding out from that point. And if I just pick a random spot and I click, you can see that down here, this little box is then kind of highlighted. So if we type 20 here and hit enter, it's actually going to put that measurement in there for a 20 millimeters for us. And then we can do the same thing here, put 50. And so now we have a part that is 50 by 20. And if we uncheck the, or click on the center point rectangle so it's no longer selected, we could then select this, select the measurement, and drag it over so it's just a little bit cleaner, a little bit easier for us to see. So that's our basic measurement, but we want our part to look a little bit cool. So this sketch fillet tool will create a radius on two lines for us, kind of at a corner. So if we click on this tool, we can click this line, and then it's already got a radius of 5 in there. We could change it, but I like the radius of 5, and so then it's telling us if we left click on the mouse, it's going to set that value. So we'll go ahead and do that. Then we can click on this top line here, and that sets that radius. So we'll just find an open space where we can left click. We'll click on the bottom and then the right, left click, and then the left and the bottom and left click. And so now you can see hitting enter to clear that box, you can see that we have a nice little part kind of all drawn out here. Now we're not done with this sketch just yet because we're going to need to create some screw holes for this. So let's go to the center point circle tool, and if you notice, this centerpiece highlights, and then you have that dashed line. And what that's telling us is, hey, we're going to constrain this parallel to the center, which is great. That's exactly what we want. In fact, you can see the little constrain parallel icon that pops up. If I move off to this side, it goes away. If I move back, it shows it again. So then I can click here. So because I'm going to be using M4 screws, what I want to do is actually set this to be like a I can just click here. It's going to ask me, this is 9 millimeters. It's not what I want. I'm going to do 4.3, and that'll give me a nice little screw hole for the M4 screws to fit in. But you notice it's in blue where all of this is in black. And what that's telling us is that that's not fully constrained, meaning that it could move around. I'll show you that in a second. But first, let's go ahead, and you can see if I let it highlight that center dot and I drag all the way down there, I'm still getting that parallel constraint. So I can click, I can drag it open, and then again, I can do 4.3, hit enter, and it's going to create that screw hole that's constrained to 4.3. Now, why is it telling us it's not fully constrained? Well, if I click here, I can move this up and down. So it's like, I don't know exactly where you want it. And if you were to make some changes, it could be in the wrong place. So what we're going to do is this is the dimension tool. It's also a D is the shortcut. So we're going to hit D for the shortcut of the dimension tool. We click the D tool, and then we're going to click the bottom and the center hole. We're going to drag this off, and you can see it's giving us a measurement there. We're going to put 10 millimeters in here. And then you notice that this one's not blue, but this one is still blue because this one's not fully constrained, but this one is. So if we hit this center dot and then this line, I come off and we say 10. Now we have a fully constrained drawing with, all the various pieces of bits and bobs that we want in there. So this is really sufficient at this time for this sketch. One other thing we could do on this sketch is we could drop down and do a corner rectangle. And what we could do is zoom in just a little bit. And I have to hold down Control and center mouse button to pan the view. The reason I have to do that is because under my account and under Preferences, I have selected mouse control SolidWorks because I want my mouse control to mimic SolidWorks. I've never used SolidWorks before. That's not the default setting, but I always kind of figured maybe at some point in time, because SolidWorks is the industry standard, I might use that. So better to get comfortable with it now. So that is just something that you could do. So your controls may vary a little bit, but for me, I'm just going to go back to the sketch. And again, I can click on this left plane. I can hit the in button, which will normalize my view. I can double click that sketch. That gets me back into the sketch. And then Control and middle mouse button scrolling in gets me closer. But Control and middle mouse button allows me to pan around. So let's grab that corner rectangle. And then I'm going to make sure the top line is highlighted. And then I'm going to click the corner rectangle. And then I'm going to drag it down to about here and just click. Now, depending on what aluminum profiles you're using, you may need to change these dimensions. I have 40-40 profiles. If you're using, so for me, my measurement here, this one is going to be 7.5 for me. Now, if you were using something more like a 2020 profile, you probably want to use something like 6.5, but it would be good for you at this point to have a micrometer, something just like this here, and go ahead and measure exactly what you want your standoffs to be. So for me, it's 7.5. And then I'm going to go ahead and hit the dimension tool. I'm hitting D so that it's selecting dimension. I'm going to highlight the center line, and then I'm going to highlight this right line. Click that. And because it's 7.5 and I want it right in the center, I need to do 3.75. So that's going to set it right in the center. And you notice this line is not constrained. So I can actually click on this line here and drag out and then set 5. So now we have that all drawn up. But there's one other problem we have because this is going to end up being a standoff. You'll see that in a second. But I want this down here as well at the bottom. So what I can do is I can use the mirror tool. So if I click on mirror, you'll see it says select a mirror line. So we're going to hover over the horizontal line so that it's lit up. Click that, and now it says select the entities to be mirrored. So we're going to click on this line, this line, this line, and this line. And then we can click off the mirror tool. And so then you see it created this down here, and then it has those funky little Roman or Greek characters. And what that's telling you is that this is constrained by a mirror. So that's what that's for. So that gives us kind of the base of our part. So we can go ahead and hit the checkbox on sketch 1, and you can see what we have, a fully constrained sketch. If the sketch isn't fully constrained, you actually get a warning here. But now we have our sketch right there. So now what we want to do is turn that sketch actually into something. So we're going to go ahead and click this extrude, select solid and new. So this is telling it I want to create a solid new part. And we can click right here. Let's make it 5 millimeters because we're just going to, let's make it 10 millimeters. We want a little bit of a heavy duty part there. So we've got a 10 millimeter extrusion there. Let's go ahead though and select this line or this piece and this piece as well. So it fills that in completely. And then we can go ahead and hit the checkbox. Now what we want to do is we can go ahead and show this sketch because we have more we want to do with this sketch. We can hit extrude again and we can select here and here. But this time, if we change direction, we can see that it's creating those standoffs. And so when our part fits into the aluminum extrusion, that's it's going to slot in there, and that'll help prevent it from rotating. But we don't need it 25 millimeters, so we can actually just sell it. Let's make it 5 millimeters. And so that'll create those for us. So there we go. So, I mean, technically, we could now print this and use it. It just doesn't do anything. So we want to do a little bit more. And just to be a little bit fancy, before we move on to the next section where we actually create the hook for our filament spool, let's go to the chamfer tool. And if you're using countersunk screws, this is a great thing to do, right? The M4 countersunk screw is about 3 millimeters for that, for kind of the countersunk piece. And so then we can click there and there. And so then that will help us ensure that our screws are kind of flush mounted there. So now we need to create our hook. So if we just go ahead and click on the front piece, we can click sketch, and this time to sketch, we actually want to make sure that we have this piece of our part selected. And so then you'll notice that we're actually sketching on the face of extrude 1. So we're actually sketching on this face right here, which is great. So we can hit in, normalize that up. We'll grab the corner rectangle tool. Make sure you have this corner highlighted. Click, and then just slide your mouse down to this side till this line is highlighted. Click, and that ensures we constrain the width of this sketch to the width of that extrusion. So if we were to extrude more, because we're like, oh, 10 millimeters is enough, let's go ahead and make it 15, it's going to extrude this sketch as well. It's going to lengthen the sketch as well. And so then in terms of the height of this, let's go ahead and make this, let's just say 20 millimeters. I think that's a little more than what I actually did on my original part, but that's okay. So we have that now. So now we can just check this off. We can select the extrude again. This time we want solid and add. So when we say solid and add, we can actually click right here. It extrudes this out, and you see it already added the merge scope of part 1. And what this is saying is it's saying, okay, we're going to add this extrusion to another part, but it auto-selected part 1 because part 1 is our only part, and it's the only part that this piece touches. If we had, like, if we extruded this in a way where it actually wasn't mated up against part 1, we would get an error because it's like, hey, I can't add this to part 1. So this kind of shows us that it's adding it right to part 1. Now, a couple of things that we have to think about here, right, is how long do we need it to extrude out? If you're using 2020 profiles, you may not need to go as far out as I do. I actually have to extrude this out 40 millimeters so that I get it beyond the profile, get enough room to get my steel bar hooked into it, and then hang my filament spools on it. So I'm going to do 40. And that's all I need for this. I can go ahead and click here. Again, not looking very cool. So we can use the fillet here and select this angle and then say 12, let's do 15 millimeters. And so then you can see we get a nice little swoop up, kind of gives our part a real cool look. And let's do a little more of that just to make it a little nicer, but let's say 3, and we can click here, and that'll give us, you know, a nice little just a nice little fluid motion there. Let's use a different word that I can actually say. And then the same here. And so that kind of makes our part just look like a very nice fluid part. We can even add one here. And so the next thing we need is we need the actual channel for our filament rod to go into. So what we can do is, again, we'll do another sketch. We'll go ahead and sketch right on this. So again, we're sketching on a face of extrude 1. And then we can grab this circle. And then let's just pick a random spot in here. And because my steel dowel that I'll be setting in this is 12 millimeters, I'm going to make this 14 millimeters. So that's the length of mine. I'm going to hit D, because as you can see, this isn't fully constrained. I'm going to hit D. I'm going to click the center hole, and I'm going to click this top line, and I'm just going to make this 4 millimeters from the top. And then I'm going to click this the center again, and then this dot here, and then let's go ahead and make this just 25 millimeters. And so again, that fully constrains our sketch, makes it look really nice. And then if anything was to change, it would ensure that this punch out that we're about to make is always only 25 millimeters from the edge of this part. So we're going to go ahead and check OK. We're going to hit extrude again, but this time we're going to say solid and remove, and we're going to click here, and it's removing that. Notice it said merge scope is part 1. You can have multiple merge scopes. So if we had multiple parts and we actually wanted this same hole to be punched through all of them, we could add them. Another thing you can do here is you can say through all. And what that does is it actually, you can see there's no longer a 25 millimeter listed. And so it just ensures that it's going to go through this part and then stop. And the nice thing about that is if you had another part right after this one and you didn't want it to punch a hole through that one, by making sure you do through all, you can make sure it just punches through what you want it to punch through. So we can go ahead and check that. Now, as I'm looking at this, I'm thinking, man, that nice little second set of fillets that I made, I like these two edges to be on that fillet. So I can actually click here and drag this down. And what this does is the layers here are the order of operation. So it's going to do this, do this, do this, do this, this. So if I had left it up here and done this fillet, you can see my punch out's not there, so I can't select any of those parts. But if I hit X and I drag this down below and I double click on it, now my punch out's there. I can go ahead and click, and you can see now I've got just a really nice dip that will hold my dowel really nicely, get it locked into place, and allow me to hang my filament spools from it. Now, one of the things I'm a little concerned about, though, is this right here. Could this break? And one of the things you can do in this instance is you could actually create a rib. So if we go on the right, if we click on the right side, and here's something interesting, especially if you're making these parts to be printed by a 3D printer. We want to create a rib. Now, if I create the rib on this side from here to here, or in the center from here to here, right? And so I created the rib there. I'm going to have to create supports, and those supports will have to hold that rib up as we're printing, right? If I do it on this side, right, from here to here, again, I got to have supports, right? Because you got to think about how is this going to be oriented on the print bed. Like if this is the face if this face here is against the print bed, I would need supports to hold up these standoffs and this curve. If this face was the print bed, I would need supports for this piece, this piece, this piece, and whatnot, right? So this piece is our best piece for being on the print bed. And because these chamfers are 45 degrees, most 3D printers can print a 45-degree angle without supports. So we shouldn't need supports for this piece. So this is the piece we want against the print bed. So if we're gonna add a rib, just an additional support piece, it would be good if it was aligned with this face. So I'm gonna go ahead and hit sketch. I'm gonna say, let's sketch along this face. I'm gonna click the line tool, and I'm gonna click here, and then I'm gonna click there. And so because I'm clicking here and here, we actually constrained to those points. Now, sometimes you'll find that you have sketches where you have multiple layers and multiple levels of sketching. And for some reason, you're like, man, I know there's a point there, but it's not selecting it. In that instance, you can use this use project, where you can actually click on the use project, and then you could select this line, and now this line becomes a part of the sketch you're currently working on, even though it wasn't originally a part of this sketch. You can click on just this point and make this point a part of this sketch. Because of the way we made our sketch, we don't actually have to do that. So we can go ahead and just click OK. And so you can see we have this nice little line right here. And what you could do is you could just easily extrude this, and you see it's extruding the wrong way and it's saying solid new. So now down here in our parts list, we have two parts. Again, not what we want. So we can flip it and say add. And so now it's adding this part, and that second part is gone. But again, that's way too much. So you could say 2 millimeters. And then that kind of creates a nice little rib for it that we can work with. Now, if we're looking at our part here and we're saying, Actually, I would like it if it came out from here to here, give us a little more support, right? We can go back to our sketch. We can click on this constraint and we can delete it. Now you can see our part's not fully constrained. So if we click on this coincident constraint, we click here and then we click on this here, and then we could do the same thing here where we click on this coincident constraint, hit the delete key, delete it, click on the button to recreate it, click there, and then click there. Now if we click the checkbox, now we've got that all the way through, creating a really solid part that could hold a lot of weight. So because we're printing it on our print bed and it's going to print like this, our layer lines are going this way, which would give us the optimal strength for this type of part. If our layer lines were going across it, we could potentially put weight on those layer lines, pulling those layer lines apart and breaking our part, which we don't want. So that allows us to create this whole part, right? Now, you might be thinking we have a problem, right? Because we've created this entire part, but we need two of them. And so now I've got to do the whole thing over again. Not exactly, because remember, we created that first plane and we offset it. So if we now use this mirror tool, it says entities to mirror. So we're going to go ahead and select part one. So now part one is in our entities to mirror. We click on mirror plane and then we select the right plane. Now you can see we've created two parts, left and right. So if we right click on our parts studio, we rename this and say, let's call this filament rod holder. And then here we can right click and say rename and call this left, and right click here and rename and call this right. And then if we export this, you can see that it exported filament rod holder left.stl. So let's bring this into Orca Slicer and see exactly what it looks like. Okay, so now in Orca Slicer, we can go ahead and click on Add, import that model. We can go ahead and auto-orient it, see just how it will print. One of the things we can also do is we can go to Support Material, turn that on, and then just slice. And after we slice it, we can see that it's going to take about 30 minutes to print this on this printer. It doesn't generate any support material anywhere. We could also go ahead and export the right one as well, orient it, and then arrange the parts in such a way that works good for printing, slice it, and we can get all of